Most digital twins today are custom, one-off scripts. They don't scale and you can reuse them on the next project. In this video, I'm going to show you a different approach, applying object-oriented thinking to industrial digital twin, a methodology I call Object-Oriented Industrial Digital Twin, or OOIDT. The idea is simple. Instead of writing custom script for every valve, we build reusable industrial objects that can be instantiated across a system. In automation, we don't rebuild logics from scratch for every device. We define a function block once and we reuse it everywhere: pumps, motors, valves, sensors. That's what makes real industrial systems scalable. In this project, I apply the same philosophy to a digital twins running in Sim. Instead of building custom scripts for each valve, we build one's action graph model node. That's what makes digital twins scalable, just like a modern software. Let's start with the PLC. I'm using FactoryTalk Design Workbench with a Micro850 L50E controller. I created a user-defined function block called valve, which captures the behavior of the typical on-off process valve. It includes commands like manual request, open request, auto request, feedback such as feedback opened, feedback closed, a status bits like status open, status manual, status auto, and status faulted. This keeps all the logic synchronized, maintainable, and reusable. Then I created 3 instances: VA01, VA02, and VA03. Each one represents a real industrial valve with its own state and behavior. I don't rewrite logic for each valve, I just reuse the same block with different parameters. This is object-oriented automation at the PLC level. Now, let's mirror this structure inside the digital twin. Can a visual valve behave like a real valve without custom scripting for every instance? That's what we are doing in Sim. In Sim, I imported 3D valves and connected them to a PLC through a small action graph. To read that from the Micro850, I used a small Python library called Pylogix. It gave me a fast and simple way to connect to a Rockwell PLC over Ethernet IP, which is perfect for rapid prototyping. In a real industrial system, I will normally use OPC UA for secure communication. But for this prototype, Pylogix lets me move quickly and focus on the architecture. The valve controller maps PLC state directly to simulation behavior. The logic is close to what we would expect in real plan. When the valve is open and healthy, it's turned green. When it's in manual mode, the side turns yellow because manual mode needs operator awareness. And when there is an alarm, the head turns red because safety always overrides everything. This gives us an immediate visual understanding of what is happening without reading numerical values. What makes this system scalable is not animation, it's the architecture behind it. I created a reusable action graph valve block in Sim. It has input parameters, tag from PLC connected with Pylogix, the base tag name, and the prime path of the UDFB valve. Internally, it automatically generates tag name like VA01 statue open, VA01 statue manual, and VA01 statue faulted. So if you want to add a second valve, we imported the same action graph block, change the tag and point it to a different mesh. I don't rewrite script, I just create new instances. Here are the 3 valves running in the real time. On the left, VA01 in manual mode, it's yellow. In the middle, VA02 is in auto mode, so it's green. On the right, VA03 is in alarm, so the head is red. When I toggle bit in the PLC, the simulation updates instantly. This creates a direct link between real industrial logics and the digital twin. This small example represents a big shift, what I call object-oriented industrial digital twin, or OOIDT. Instead of script for each valve, I'm building reusable components that scale across a plant or across a multiple simulation project. This is how we move from prototype to system, scalable, maintainable, and extensible. In the next videos, I'll extend this approach to pumps, tanks, and sensors, and build more advanced industrial process around it. This is just the beginning of the object-oriented industrial digital twin, where industrial systems are built once and used everywhere. If you are interested in automation, digital twins, or real-time PLC integration, subscribe and feel free to leave a question or suggestion. Thanks for watching and see you in the next one.